The position of an object moving along a straight line is given to you by the function s of t equals 5t to the fourth minus 16t cubed plus 8t squared, where s is measured in meters and t is in seconds. Find the velocity function. Well, the velocity function involves me just taking the derivative of the position function, and that's it. Not plugging in anything, that's it. So the velocity function is going to be s prime of t equals power rule, power rule, power rule. So drop down that 4, 20t to the third, drop down that 3, 48t squared, drop down that 2, 16t, and that's my velocity function. No harm, no foul. Easy peasy lemon squeezy. B is what is the object's acceleration at t equals 2 seconds? Well, the acceleration function is you taking the derivative of the velocity function. And so I need to do that and then plug in 2. So s double prime of t is going to be power rule, power rule, power rule. Drop down the 3, 60t squared. Drop down the 2, 96 regular t. Get rid of the t, 16. Now I'm going to plug in 2 into that equation right there. So s double prime of 2 is going to equal 60 times 2 squared minus 96 times 2 plus 16, and we just have some ugly math. 60 times 4 minus, what is that, 192 plus 16. 240 minus 192 plus 16 is going to be 64. Now, do I have any units? Do I have any units? Seconds, meters. So this is going to be meters per second squared. Okay, velocity would be meters per second. I didn't have to do that. But now I have meters per second squared. Okay? Now, the third question is going to be the grossest one of the three. At what time does the object change direction? Okay, now direction changes when velocity either goes from positive to negative or negative to positive. Okay, positive velocity in this case means you're going to the right. Negative velocity means you're going to the left. So if you were to go from right to left, that means you just changed direction. So I care about what we did in problem A and finding out where that happens. Now that's going to happen at a critical point. Okay, and in this case we might have 2 critical points, maybe even 3. So we need to find those critical points. So problem C involves me taking the velocity function and setting it equal to 0. So 0 is equal to 3t cubed minus 48t squared plus 16t. I have a 4 and a t in common with all of those, so let's rip that out. 4t, that's going to leave me with 5t squared minus 12t plus 4. So let's see if I can figure that out. So I'm going to have a 5t and a regular t. Those are my options. And positive 4 is going to be minus and minus. 2 and 2? Yep, that'll do it. So I have my 3 possibilities. And I'm going to be careful here, but all of them are going to work. 0 is going to be my first one. Okay. This one I'm going to set equal to 0, so 5t minus 2 equals 0. So if you add 2, you get that, and if you divide 5, you get that. And then t equals 2 is my other option. So I have 3 spots where at the very beginning, technically, you do have a direction change, so that kind of, I don't feel right saying at the beginning, but I'm going to say it anyway because it's a possibility, it's an option. Okay, it changes direction at 0, so I guess technically you're fine. But my seconds are going to be 0, 2/5, and 2 seconds. Of course, that's not in order, but who cares? Now, what you have to be careful of is what if any of these were negative? Well, if any of them are negative, then that's not an option because you can't have negative time. But yeah, that's what we're going to get here. So, fun stuff.